Good morning. Today I am going to explain logic gates. Logic gates are classified into three categories. One is basic gates, the second one is universal gates, and third one is special gates. These logic gates are basic building blocks for any digital circuit. In basic gates, we have NOT gate, second AND gate, and third one is OR gate. In universal gates, NAND gate, second one is NOR gate, and in special gates, XOR gate and XNOR gate. So we'll discuss these all basic gates, universal gates and special gates in detail. First one is NOT gate. NOT gate is a single input and single output gate. Let us see the symbol for the NOT gate. Symbol becomes, so this is the symbol of NOT gate. So here it comes input and here it is a output. Let us denote the input and output with some variables. Input is A and output is Y. Here Y is nothing but Y is equal to A bar. So let us see the truth table. The truth table of NOT gate is A, Y is equal to A bar. If A equal to 0, then A bar becomes 1. If A equal to 1, A bar becomes 0. So a NOT gate does the complementation of whatever the input you supply. Here we have supplied A value 0, then output became 1, A value equal to 1, output became 0. So it does a simple complementation. Next it comes for AND gate. Symbol for the AND gate. This is a symbol of AND gate. It contains minimum 2 inputs and maximum 1 output only. A and B are the inputs. Let us denote, and Y is equal to A dot B. This dot indicates multiplication or AND operation. The truth table of AND gate is, here we have two variables A and B, so we are going to get 4 combinations. This is for A, this is for B, and output Y is equal to A dot B. A equal to 0 and B equal to 0. A dot B, the result is 0. If A equal to 0 and B equal to 1, the result is 0. A equal to 1, B equal to 0, result is 0. A equal to 1, B equal to 1, the result is 1. From the truth table, we can conclude that if any one of the input is 0, the result is, obviously it is 0. So if you observe here both the inputs are 0, result is 0. In this combination, the one input is 0, the result became 0. Here one input became 0, the result became 0. So it does a simple multiplication. Next one is OR gate. The symbol of OR gate is, this is the symbol of OR gate. Contains minimum 2 inputs. It needs minimum 2 inputs and always the output is single output. So Y is equal to, here Y is equal to, the OR operation is denoted by plus symbol, AND operation is denoted by dot symbol, OR operation is denoted by plus symbol. If I draw the truth table of this OR gate, this is A input, B second input, Y is equal to A plus B, or A or with B. 0, 0. If A equal to 0, B equal to 0, A or B is 0. A equal to 0, B equal to 1, A or 0 or 1 is equal to 1. Next, A equal to 1, B equal to 0, 1 or 0, that is 1. Next, A equal to 1, B equal to 1, 1 or 1 is 1. So if you observe here, if at least one input is 1, then the result became 1. So this is about your NOT gate, AND gate, OR gate, basic gates. Next one is NAND gate. This is the first universal gate. Why it is called as universal gate? Because we can implement or we can realize all other gates with the help of these NAND or NOR gates. That's why these two gates are said to be universal gates. First gate is NAND gate. The NAND is nothing but, if you observe here, there is a AND. So what will be the relation between NAND and a basic gate of AND? And NAND is nothing but, and NAND gate is nothing but, it is AND operation or AND gate plus NOT gate. AND gate plus NOT gate. Already we have seen what is the AND gate in the basic gates. So let us draw the symbol of this AND gate. This is the AND gate, and add with NOT gate. AND gate added with your NOT gate. So this is A and this is B. Or connect. So if I connect a AND gate with one AND gate with A, this is AND gate. Next, connect with the NOT gate. If you observe here, what is the output you are going to see? A, B are the inputs. Here A dot B is the output for the AND gate. If A dot B is the input for this NOT gate, obviously you are going to get A dot B whole bar. So this whole system, if I include in one box, so if I consider A and B are the inputs, A dot B bar is equal to output. So for NAND gate, the relation is Y is equal to A dot B whole bar. This is the output equation for NAND gate. So connect AND gate with the NOT gate. The actual symbol of NAND gate is like this. So this is the symbol of NAND gate. That is AND gate with a bubble at your output side. A and B and Y is equal to A dot B whole bar. So if I keep a bar on your A dot B, that becomes your NAND gate result. So if I draw the truth table of NAND gate becomes A and B, A dot B whole bar. 0 0 0 0. Actual 0 and 0 is 0, but it is complementation 1. 0 comma 1. If A equal to 0, B equal to 1, here is 1. For 1 0, 1. For 1 1, it is 0. So if you observe, let us consider AND gate truth table. Let us compare AND and NAND. 0 0 0 0 1 0 1 0 0 1 1 1. So this is A, this is B, and this is A dot B. This A dot B is nothing but AND operation, and A dot B bar is your NAND operation. If you observe these two truth tables, exactly it is complementation of NAND gate truth table is exactly the complementation of your AND gate. Here you have 0, here it became 1. Second 0, here it became 1. And third row 0, here it became 1. The last 1 1, it became 0. So NAND is nothing but the complementation of AND is called as NAND. Next, NOR gate. Next one is NOR gate. Again, if you observe, there is a OR symbol. So NOR is nothing but OR followed by NOT gate, OR followed by NOT gate. So if I draw, so this is the OR gate followed by one NOT gate. So this is the input A, this is input B. So from OR operation, so at this point you are going to get the result is A plus B. If A plus B is the input for NOT gate, the result becomes A plus B whole bar. So if I include this OR gate and NOT gate in one box, A comma B are the input, A plus B bar is your output. So the Boolean expression for OR operation is A plus B whole bar. The actual NOR gate symbol is, this is the NOR gate. A is the input and B is second input, and Y is equal to A plus B whole bar. A plus B whole bar is NOR operation. Here it needs minimum 2 inputs and maximum it contains only one output line. The truth table of NOR gate is A, B, A plus B whole bar. 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. So let us compare this NOR truth table with OR truth table. A, B, A plus B. 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. So if you observe the truth tables of NOR and OR, the NOR truth table is exactly the complementation of your OR. That's why NOR is nothing but it is a complementation of OR gate. Next, the last one is special gates. In special gates we have two types, XOR comma XNOR. XOR and XNOR. Let us see for XOR. The symbol of XOR gate is A is the input and B is next input. So this is the symbol of XOR gate. The relation between your input and output is Y is equal to A XOR B. A circle on your plus symbol is indicates your XOR operation. If I draw the truth table, A, this is A, B, Y is equal to A XOR B. 0, 0, 0, 1, 1, 0, 1, 1. So with the two variables we are going to get your 4 combinations. So here it compares XOR gate, it acts like a comparison. So it compares the inputs. If the inputs are same, the output is 0. 0, 0 inputs are same, 1, 1 inputs are same, the output is 0. For remaining 0 and 1, the inputs are different, output is 1. For 1, 0, output is 1. Next, the last gate is XNOR gate. XNOR is a complementation of XOR gate. Here Y is equal to A XOR B complementation, or Y is equal to, we can write it as A dot with B. This is a XOR gate. XOR gate Boolean expression. The symbol of XOR gate is, this is the symbol of XOR gate, XNOR gate. A, B, Y is equal to A XNOR with B. So XNOR is exactly the complementation of XOR gate. If I draw the truth table of XNOR gate, A, B, A, XNOR with B. The two variables we are going to get 4 combinations. So here it is exactly the opposite of your XOR gate. For 0, 0, here it is 1. For 1, 1, it is 1. For remaining it is 0. So this is about your logic gates and their symbols and truth tables. So we have seen in this class the basic gates, universal gates and special gates. Thank you.